Okay, here's what's going to be on the quiz that is not in the Google slide presentation. I want you to write this down, and I'm going to spell it for you right now. So I'll give you a second to grab whatever you need to write this word down, because it's the word you need to remember. It's called demosaicing. If you know what a mosaic is a bunch of little tiles put together to create a picture. That's what a mosaic is. If you look up mosaic in Greek art or old ancient art, they still do it today. You see a bunch of tiles put together. So that's mosaic, and this is called demosaicing. That's the word I want you to write down. It's DEMO, like demo, SAICING. And what this is a process where on these chips, what can happen is what they do is they'll put in an extra green layer. So there's red, green, blue, RGB. You've probably heard a lot. They put in an extra green layer because it's actually more how our eyes work. Our eyes tend to pick up green more than others. And what happens is, because you have two layers of green, which they don't tell you about in this, but they have two layers of green and then a layer of red and a layer of blue. I'm not sure if all image sensors do this, but two layers of green, one red, one blue. In order to interpolate the colors correctly, because normally there's just red, green, blue in the world of RGB, obviously, it guesses as to what the actual color will be. So there's a process that it transfers the concept of what is coming through the lens, and it says, okay, this is the image, this is the information we're getting through this process, but the actual color is going to be this color. That's called demosaicing. That's on the test. It's question 10, I believe. So that's all you need to know. If you wrote that down, you will be good. Thanks for being here. Lorenzo just showed up. Lorenzo just showed up and just missed what I told him. So you're going to have to go back and watch the recording. I will put the recording on Google Classroom later today. Okay, so back to the actual video. I'm sorry, the actual slideshow. There we go. Okay. Oh boy. Let me refresh this so I can present it correctly. Okay, so the image sensor is two types. This is what I was just talking about, the pros and cons that were listed here. I will quickly go over it now. You come back to this when you take the quiz. CCD, charge coupled device. You don't have to know that for the quiz, but that's what that stands for. It's used in broadcast cameras still today because it provides a better image quality. However, it's susceptible to that image blooming smearing effect. And what that is, blooming smearing, is just that light, being exposed on the image sensor right there in such a way that it creates problems in your picture sometimes. And then the CMOS, complementary metal oxide semiconductor, is used in phones, webs, DSLR cameras, and more. And actually, it's starting to be used in some broadcast cameras in what is not the most professional ones, but below that, which sometimes are called prosumer cameras. The CMOS is cheaper to make and faster. It processes stuff faster. But it is susceptible to that rolling shutter, which is, it's taking the image left to right. I think I'm doing that right for you because it's right to left. For you guys, left to right, unless it's a mirror, I don't know. And what that does is you'll get, if something's moving very fast, you'll get like a blurring or weird effect sometimes. Okay, so for lenses, there's a lot of vocabulary here. I want to make sure you know. Lens should be pretty obvious. It's just a piece of glass with curved sides that bends light. There's multiple types of lenses. Your glasses, if you're wearing eyeglasses, it's obviously convex, which is the next vocabulary word. It kind of bends out, but but lenses can be concave, which we'll come to in a second. They can come in all shapes. The major two shapes we're going to look at here are convex and concave. So convex is a surface that is curved like the exterior of a circle or sphere. So convex is like this. It can be convex on one side and flat on the other, or as you'll see, concave. It can be that way as well. But generally speaking, when we're talking about a convex lens, it's like this. Focal point, it's the point at which rays or waves meet after refraction. And we're going to watch a video that explains all this, but I wanted to touch upon all this vocabulary before we get into it. So the focal point, what's happening is you have your lens here, and you have light rays that are coming in straight like this at all different points, and all this light waves are coming in like this. And when it comes into the convex lens, what happens is the convex lens will bend that light in a different direction. And when it bends that light, it's going to meet at a focal point. In the video, you're going to find, you're going to discover there's a couple of problems with the focal points, and we'll get to the vocabulary for that in a second. Refraction just means it's a change in the direction of light. In this case, it's a change in direction when passing through a medium. So it's passing through the lens. Refraction is that bending. Converge is when things come together. So it could even be two people walking along and they get closer and closer and they meet, they converge. In this case, we're talking about the light is converging towards that focal point. Multiple items meet at a point. Spherical aberration. Aberration means like some sort of oddity or an error that is caused. And a spherical aberration, again, which will be in the video, is a loss of a clear image definition from a spherical round lens. They will explain to you what happens is when you have that convex lens, what's happening is the light that's coming from here has a different length than the light coming from the middle because this is closer. And so it causes this aberration that needs to be fixed. Chromatic aberration is has to do with the length of color waves. So blue waves are a different length than green waves are a different length than red waves when they pass through the light. You might have learned this in your science classes. So it causes a chromatic aberration, which is a failure to focus, causing colored fringes, or I said blurs. Fringe is like this, but to me, it's just a blur in an image. Concave is the opposite of that convex, so it's like this, as you can see on the right side of the screen. And distortion is when something is pulled or twisted out of shape. So let's move on, and we're going to watch this next video.
If you look at a scene through a single lens, it appears upside down. Why is that? Lenses that are thicker at the middle are called convex lenses. These lenses cause parallel light rays to converge to a single point, called the focal point. When light rays pass through the lens, they do not travel in straight lines, but rather bend slightly inward. This phenomenon is called refraction. When light rays pass through the lens, they refract and converge to a single point to produce an image. Because the image passes through the lens to the opposite side, it is projected upside down. This process alone, however, is not enough to produce a sharp image. This is because, strictly speaking, a spherical convex lens alone cannot cause light to converge to a single point. The focal point where light rays passing through the center of the lens converge differs slightly from the focal point where light rays passing through the edge of the lens converge. This is called spherical aberration. In addition, color fringing may occur. This is called chromatic aberration. When light passes through a convex lens, the focal point for red light, which has a long wavelength, is farther away from the lens than the focal point for blue light, which has a short wavelength. This causes colors to shift. As a result, colors appear to bleed. Making light converge neatly to a single point requires technology. since the direction in which spherical aberration occurs in a convex lens is opposite to a concave lens, through a combination of 2 or more lenses, light rays can be made to converge to a single point. This is called aberration correction. Chromatic aberration can also be corrected by combining 2 lenses. To achieve the most beautiful images possible, actual camera lenses incorporate multiple individual lenses that correct focus and color bleeding. Lenses for single-lens reflex cameras are made up of a large number of lenses. Each lens is responsible for such roles as adjusting colors, distortion, and focus, as well as changing the focal distance. Canon takes pride in its diverse lens lineup. Each model features technology designed to capture beautiful images.
Oops, sorry about that. Cut it out. Okay. I got to get a better handle on this, as you can tell, but that's okay. So the camera body is the easiest thing to remember. The main box of the camera that holds the lens, image sensors, viewfinder, and electronics, the body. Makes sense. You just have to know that it exists. And the viewfinder comes in, generally in 2 paths. We have, as you can see in this picture, the screen, which is a digital screen, probably an LCD screen in most cases. And then there's the viewfinder that you look through, the eye hole viewfinder. So there's those 2 types of viewfinders. Remember from way up here at the beginning that the viewfinder that you're looking through with your eye can be presented of the actual image being bounced through a series of mirrors, or in a mirrorless camera, it's presented on the image sensor, and then you have your digital display that will come through the eyepiece. So remember that. Neither of those things will be on the test. Here's a little bit of a review in case you need for all of those things at the very end. I'm going to go ahead and stop my share. You have, let me unmute all. And does anybody have any questions at this point?
No.
No?
Nope.
Okay, great. So in Google Classroom, you have an assignment that is this PowerPoint presentation, and you have the quiz. Take the quiz there, but make sure that you know that all the answers are in the PowerPoint presentation. So there's no reason to get less than 100% credit unless you did not watch this full video, because there's that one question that I gave you the answer only in this video. And then after that, go ahead and take a look at the Adobe install. Right now, it's, you have a little less than 20 minutes left before your next class. So take it to do the quiz, or you can take the quiz later, however you want to handle it. But I'd like that quiz done by next class, please, so that I could grade it and get it back to you. And as far as installing Adobe, we're not doing anything with Adobe yet. I would say go ahead and see if you can get it done before next class, just so I could address any issues. So that's all for this session. I'm going to go ahead and end this session. That's it. I hope you all do well, and I'll see you on Wednesday. Bye now. Hey, Mr. Cashman. Bye.